So this girl is flying from Boston to Denver with a connection in Chicago. The probability her first flight leaves on time is 0.15. So, hang on just a second. That's an event. So let's go ahead and define it. Let's call that event A is the event that the flight leaves on time. All right, and they actually give us a probability for that. So the probability of A is 0.15, which means that if the flight is late, then that's the complement, so that's 0.85. So we're automatically starting to see things reveal themselves. All right, so in the second sentence, it says if the flight is on time. Now the word if is a key word, just like given that is conditional. All right, we will mark that down. It's important, but for right now, let's keep reading. So if the flight is on time, the probability that her luggage will make the connecting flight is 0.95. But if the first flight is delayed, all right, another conditional, the probability that the luggage will make it is only 0.65. Well, those two conditionals share the same event, and that is that the luggage arrives with her. So let's call that event B. All right, so event B is that the luggage arrives with her. And guess what? We don't know what that probability is. We have some conditionals, but we don't actually know what the probability of B is. In fact, what is the probability that her luggage arrives in Denver with her is the probability of B. They're actually asking us for it. So back to that second line, if the flight is on time, all right, that's given A. The probability that her luggage will make the connecting flight, that's the probability of B given A. And that's going to be 0.95. So that's good, we need that. But if the flight is delayed, that's A complement. The probability the luggage will make it is only 0.65. So that is the probability of B given A complement. All right, not leaving on time. First flight is delayed. So that's going to be a probability of 0.65. All right, so with those three things, we can reveal a whole lot. And we can answer the question, what is the probability of B? That's the major thing we're after. So a tree diagram involves quite a lot of space for things. So kind of let's go down here and we'll make an initial split. So we'll start building this tree like so, and we'll just label this that the flight is on time. And we'll just label this that it's late. Now they don't give us any other options like early or anything, so don't just make those up because you're changing the nature of the problem. This is the probability of A. So that's going to be 0.15. If it's late, that's the probability of A complement. And the two have to add up to 1 because it's either on time or it's late. There are no other options. So that's 0.85. All right, we're going to build now off of this one here. The flight is on time. So given that the flight is on time, the luggage arrives with her. This will be the probability of B rather. Let me just clean that up a little bit. Let's get that off of there. Probability of B given A complement. I'm sorry, just B given A. And that's going to be 0.95. All right, this is the next branch goes like this. And let's just label this one arrives, as in the luggage. And this one we'll just label that it doesn't. All right, so given that the flight is on time, the probability that the luggage doesn't make it, that's the probability of B complement given A. Which, by the way, these are the only two options. It's either arrives or it doesn't. So these two have to add up to 1. So this will be 0.05. Now just be careful. Don't put 0.5 there. Some people leave the 0 out without thinking about it. And yeah, that's going to mess up everything. So let's branch off here. This will be arrives. And this branch will be doesn't. All right, and so the probability of it being late is A complement. See the A complement, we're on that branch. Probability that arrives given that the flight was late, that is up here. That's the probability of B given A complement. And we know that probability, that's 0.65, all right? So then it being late and it doesn't arrive, that's really the only other choice. That's going to be the probability of B complement given A complement. And there's just two ways this can happen. Either the luggage arrives or it doesn't when the flight is late. So this has to add up to 1 also. That's going to be 0.35. Okay. Many people will mistakenly stop here. We're going to find the 4 joint probabilities, the ones connected with and we're going to use the general multiplication rule, right? Because that's where we're going to dig out the B, all right? It doesn't come in the conditionals. It comes with the joint probabilities. So we'll figure out the probability of A and B, that the flight is on time and the luggage arrives with her. And that's just your multiplication rule, the general multiplication rule. It's 0.15 going up this branch times 0.95. And that'll give us 0.1425. All right, so then we'll go up this branch and then down this connector. This will be the probability of A and B complement. And again, we'll just use that multiplication rule, so 0.15 times 0.05. And that will multiply to 0.0075. Then we'll go down this branch and then up with arrives. That'll be the probability of A complement and B. All right, so that'll be 0.85 times 0.65. And that'll be 0.5525. And then the final one is the probability that the flight is late and the luggage doesn't arrive with her. And guess what? These are all the possible joint probabilities that we have. So all these 4 numbers, when we put in the 4th one, should add up to 1. So you can add these together and subtract from 1, or just multiply. What would it be? 0.85 times 0.35. And that'll give you 0.2975. All right, so those should add up to 1, all 4 of them. So we've got everything we can get using a tree diagram. We still haven't answered the question, what is the probability of B? Well, there are 2 ways that B can happen. And remember, B is that the luggage arrives with her. The flight can be on time and the luggage can arrive with her. See the B here? Or the flight can be late and the luggage arrives with her. Okay? That's the other place where we have a B. The other 2 have B complements. So with the 2 ways that these can happen, B can happen, and then being connected with an or, the probability of B is going to equal the probability of A and B, or the probability of A complement and B. And we know those, okay? A and B is, the probability is 0.1425, and or means plus 0.5525. Right? And that will give you 0.6950. That is your probability of B, and that answers your question. Great, okay? Now I just want to continue on by showing you that you can answer a myriad of crazy questions here. So this is essentially done as far as answering that question goes, but I can ask you some really strange things like, what is the probability of A given B? All right, in case you forgot, we defined those. So the flight leaves on time given that the luggage arrives with her. Let's just write that out. So this is the probability that the flight is on time. And that's given that her luggage arrives with her. All right, this is actually different than any of the four that we have above. You might think it would be the same as this one, the probability of B given A. That's the probability that the luggage arrives with her given that the flight is on time. These are different things. So you're not going to just put 0.95 down here to answer that new question because it's actually not the correct answer. But we do have formulas that will help us, and I imagine that when we write out the formula that we will have enough information from this tree in order to answer it. Now the conditional probability has a formula. Remember? This will be the probability of A and B, which we know, divided by the probability of, well, which of the two? Won't it be the B? It's always the second one in the conditional, the conditional part of it. All right, the probability of A and B is 0.1425. And the probability of B was that we just found. That's 0.6950. So there's our answer for that question, 0.2050. Interesting, all right? So good times. Now what we want to do is go into your packet, and I don't recall the page. I think it's page 12. And it's the tree diagram example, so I've got a setup for that. You know my setups are pretty instantaneous, so just hold the line. All right, back. So yeah, if you're on, I think it's page 12, you'll see these three examples. And I'm only going to do two of them. I have the third one up on the notes, but actually what we did number one here, this one, and then I let the kids do number two, which I suppose you can pause and try it yourself and then watch the explanation, but it's totally up to you what you want to do. All right, so looking at this first one, it's a classic probability question. You select two balls and there's a total of 5, one at a time without replacement. All right, the without replacement is key to this problem because that's going to create conditional probabilities. You're going to shrink your sample space. You're going to lose one ball, you're going to lose one color, one of the colors, and so things are going to get different from the start to the second pick. So there are 5, 3 red, 2 blue. Find the probabilities of all the outcomes, and I really struggled with trying to make these be A and B, or R and B, or R and R complement, and it just seemed awkward, so I didn't. I just used the words. I think you'll find that some problems are like that, and what if I had thrown a third color in like yellow? Then things really would have been hard to put into symbols. So let's just say we'll just start out here with 5 balls. And we'll do a split. And let's just say that the first one we pick is red. All right, well there's 3 red out of 5, so that's going to be 0.6. The other option would be that we pick a blue. All right, there's 2 out of 5, so that'll be 0.4. See how they add up to 1? All right, they're supposed to. All right, then we'll branch off of here, and we'll branch off of here. And let's just say that the next one we pick, once we've picked a red and we don't put it back in, will be another red, given that we picked a red on the first one and didn't put it back. So if you pick a red on the first one, you have 1 less red and 1 less ball. So that becomes a probability of 2 out of 4, which you don't have to write. I'm just putting it there, because it's notes. But that will be 0.5. And let's just say that you pick a blue, given that you picked a red. All right, well, that'll drop you down to 4 balls, and there's still 2 blue, so that'll be 2 out of 4, which will be 0.5. And those 2 do have to add up to 1, so that makes sense. All right, then let's go ahead down here and say, well, you picked a red, given that you picked a blue. All right, well, you picked a blue, that leaves you with 4 balls, and 3 of those are red, so that'll be 3/4. So that's 0.75. And let's just say that you picked a blue, given that your first one was a blue. All right, so if you pull out a blue, that leaves you with 1 blue out of 4. So that's the probability of picking another blue, 1 out of 4. So that's 0.25. So this adds up to 1, these 2 add up to 1, these 2 add up to 1. We're good to go. Again, don't stop here. The conditionals are great, but they're just a means to an end. We want the probability of all the joint outcomes. So this will be a red on the first and a red on the second, and that'll just be 0.6 times 0.5 will be 0.3. Okay? And this will be the probability of a blue I'm sorry, let's get that off of there. That would be a red on the first and then a blue. All right, so let's go ahead and correct that. So that'll be a red and a blue. And that's the same numbers. 0.6 times 0.5 is 0.3. And this will be the probability that we first picked a blue and then a red. So this will be a blue and a red. And so 0.4 times 0.75 is amazingly enough 0.3. These should all add up to 1. So this will be the probability of first picking a blue and then picking a blue. And so 0.4 times 0.25, well, a quarter of 0.4 is 0.1. And so those all add up to 1. So these 4 add up to 1, these 2, these 2, these 2. Everything is as it should be. So, may not be all that impressive, but I can ask a whole lot of questions like, what's the probability that I pick 2 of the same color? That would be this or this, that's 0.4. What's the probability that I pick 2 that aren't the same color? That would be this or this, that's 0.6. Probability of getting a blue on the first one would be 0.3 plus 0.1, which is the same as this. Yeah, so there's a bunch of questions that I can ask, all right? So then the second one here is a little bit more like Leah and her trip with her luggage and everything. So what is the probability that a high school student athlete will go on to professional sports? Well, you can imagine that's a pretty small probability. So we should get a probability that's pretty tiny. Event A is the student competes in college, and event B is that the student competes professionally. So the probability that they compete in college is 0.05, and the probability of B given A and B not given not A are both presented to us. So let's just start out with student athlete. And let's make a first branch. All right, this will be competes in college or not. So this is the probability of A, which is 0.05. And so this will be the probability of A complement, which is 0.95. And we'll just split off from there. All right, the probability of B that they complete professionally, given that they competed in college, is 0.017. And this is the probability of B given A. All right, now these two have to add up to 1. So if you subtract 0.017 from 1, you get 0.983. And this is the probability of B complement, that they don't that they're not competing professionally, given that they compete in college. All right? And so then we can split off this way. And let's see. Let's go ahead, and this is the B given not A, and that's going to be 0.0001. Make sure you don't lose zeros here. So this is the probability of B given that A didn't occur. And so this would make this 0.9999, and that's the probability of, let's get rid of that. This is the probability of B complement given A complement. All right, so those add up to 1, those add up to 1, these add up to 1 at the beginning. And so let's see. Let's just call this, just so we can complete the labeling. That's pro, that's not. That's pro, that's not. Okay, again, do not stop here, right? Go on to your joint probabilities. So this is the probability of A and B. This is that the student competed in college and competed professionally. So that would be the product of this and this. That will be 0.00085. All right, be careful not to lose zeros in this process. This is the probability of A and B complement. So that's going to be the 0.05 times 0.983, and that's going to be 0.04915. Probability of A complement and B, that's going to be 0.95 times 0.001. So that's 0.4 zeros and a 95. And then the probability of A complement and B complement, that's just 0.95 times 0.99999. So this will be a pretty big number. This is 0.949905. So there's a pretty good chance that a student athlete did not compete in high school and does not go pro. All right? But the question is, what is the probability that a high school athlete will go on to professional sports? All right? That is the probability of B. Right? So the probability of B is what we're looking for. All right? Well, again, there's two ways that B can happen. It can happen along with A, or it can happen along with A complement. So a student can compete in high school and go pro, or a student cannot compete. Oh, check that out. I said that wrong. A student can compete in college and compete professionally, or a student can not compete in college and compete professionally, like LeBron James did, or Kobe Bryant. So it's going to be the sum of those two. All right? So the probability of B, which is what they're asking us for, will be that 0.00085 plus 0.4 zeros and 95. And so your final answer for that will be 0.000945. There it is. Okay? So these are tree diagrams, and again, if you want to go ahead and give this one a go, you can. It's got three things going on. Symbolism gets a little bit crazy, but you can see how I did it. But really, probably you have enough to jump into your homework, so I would probably go there. And that previous example about Leah is actually a homework problem. Yeah, I kind of copied it not knowing it was there, and then when I looked at my key, whoops, there it was. But maybe try it on a second go. Maybe try that one first, I don't know. But just get this down, because this will help you out a great deal. And then on Monday, I'm going to show you how to do the same problems in table form. So I think we're good on this. Hopefully you have it. Definitely practice. The more that you do these things, the easier they get. You can really whip them out in a hurry.